Alright, so we're going to go ahead and continue our series on solving equations. And so let's go ahead and just dive right in. So let's look at this example here. So they say if 6x minus 2 is equal to 2a plus 3, they want to know what is 8a. So here they're not asking us to solve for a. They would like to know, well, what is 8 times a? So we can take several different approaches here, but it's all the same thing. So the first step that I'm going to go ahead and do is just copy my equation. So 6a minus 2 is equal to 2a plus 3. I encourage you to pause the video at this moment, try solving this equation, and see how you would figure out what 8a is equal to. So again, assuming that you've paused the video and you've reached some point, or maybe you've gotten stuck here, let's see if we can go ahead and work through it together. I have 6a minus 2 is equal to 2a plus 3. Again, like I said in previous videos, the goal when solving equations is that you want to isolate the variable. You want to get everything on one side. Well, you want to get your variables on one side, I'm sorry. So it looks like I have two a's here. I wish I could just move them over here and combine them with these 6a's. Well, I can do that. All I have to do is just take away these two a's. So I want to get rid of these a's here, so I'm going to subtract 2a so that they can go ahead and cancel out. But again, whatever I do to one side, I have to do it to the other side to balance out my equation. So I'm taking away 2a's from both sides here. What that's going to do is now I can just go ahead and combine these terms vertically. So 6 plus a negative 2a, or 6 take away 2a, that's simply just going to leave me with 4a. There's nothing to combine here, so this negative 2 just drops down. And again, don't forget your equal sign. And then here we have 2a minus 2a. That's going to go ahead and cancel out. And again, we're left with just a positive 3 on the right side. So again, the question is, ask yourself, well, what's being done to a? Well, we have 4 times a, and then we're subtracting 2, and then we're going to end at 3. Now, you're subtracting 2, so how do we undo that subtraction? Well, I can simply add 2 to it. So if I add 2 to both sides, let's see, plus 2, then what does that do essentially? Well, we can now combine terms vertically. So there's nothing to combine here. It's just 4a. But the negative 2 and a positive 2 go ahead and cancel out. And again, don't forget your equal sign. And 3 plus 2 is 5. Now, if we look at this very carefully, we have 4 times a is equal to 5. And if I asked you to solve for a, then what we could simply do is divide both sides by 4, and we would be done. But they don't want us to solve for a. The question is asking us for 8 times a. Well, we have 4 times a. We want to know, well, what is 8 times a? Well, can I make this an 8? And how can I turn this into an 8? Well, if you think about it, I can go ahead and multiply this side by 2, because 2 times 4 will give me 8. But if I multiply this side by 2, then I have to multiply this side by 2. So again, whatever I do to one side, I have to do it to the other. Now we can go ahead and simplify. We have 2 times 4a. So 2 times 4a, well, hey, that's just 8 times a. And 2 times 5 is simply just 10. So we solved what they wanted us to solve. We may have not finished solving the equation for a, but we found what 8 times a is. 8 times a is just 10. Now we could have taken another approach. Here's option number 2. This is what you could have also done. So from this step, we had 4a equals 5. And if I wanted to, and I wanted to undo that multiplication by 4 because it's 4 times a, I could divide by 4 on both sides, and that would leave me with a by itself, because these 4's would go ahead and reduce, and I would be left with a fraction 5 over 4. But that is what a is equal to. Oops, let me go ahead and scoot this up. That's what a is equal to, and again, the problem doesn't want a by itself. It wants 8 times a. So what I would have to do here is I'd have to multiply this side by 8, and then I would have to multiply this side by 8. Well, we can do this. This is not too bad. 8 times a is 8a. And think about 8 as 8 over 1, and now we just have to multiply 2 fractions. So what is 8 times 5? Well, that is 40. And then 1 times 4 is 4. And now we can go ahead and simplify this. Well, what is 40 divided by 4? 40 divided by 4 is just 10, which is the exact same answer that we got over here. So whichever approach that you would like to take, it'll work itself out in the end. Just keep in mind or always remember what you're looking for. And again, whatever saves you the most time in the end so that you can be most efficient. All right, so let's look at a couple of more examples here. So here we have an example where we have a square root involved. Now when you have a square root involved and x is underneath that radical, what we want to do is isolate that square root. So we want to get it all by itself. Again, it's all about undoing the equation to solve for a variable. So I have the square root, so let's go ahead and read this out. We have the square root of 2x plus 4 minus 2 is equal to 4. So again, I'm going to write out what's happening. So let's see. We start off with x. So if we start off with x, and we ask ourselves, well, what's happening to x? Well, if you start off with x, it looks like we're multiplying by 2. So we are multiplying by 2. Then what happens after we multiply by 2? We add 4. So that's the third thing. So we add 4. And then after we add 4, it looks like we take the square root. So take square root. And then after we take the square root, it looks like we're subtracting 2. So step 5, we subtract 2. And then after we subtract 2, it looks like all that should just equal 4. So we end with 4, right? So all of this, after we do all these steps to x, we end with 4. So I want you to think about how you would undo this equation here. We can simply work from the bottom up. So if we're going to end with 4, our first step to undoing this equation is that we would start with 4. Okay, so we would start with 4. So it would look something like this. So 4. We start with 4. All right, 2. How do I undo the subtraction by 2? Well, I would add 2. So I have 4 plus 2. So, well, I had a 4. Now I'm going to add 2. So 4 plus 2 is 6. So I'm at 6 now. Oops, let me go ahead and zoom out a little bit. Okay, so there we go. So I'm at 6. So I started here. I'm going to add 2. 4 plus 2 is 6. If I work my way back up, let's see. This is at 3. Well, I took a square root. So how do we undo a square root? Well, we square both sides, right? To undo a square root, we can take its square. Well, we had 6. So if I square it, I end up with 36. So now I'm at 36. And we've undone the square root. So here's what we've taken care of. We've taken care of the subtraction. We've taken care of the square root. Now we're up here. So add 4. So again, I'm looking up here. It looks like I'm adding 4 to x there, or to 2x. So how do I undo the addition of 4? Well, I can simply just subtract. I can subtract 4. Well, I had 36. So 36, take away the 4, gives us a 32. And we're almost done here. We're multiplying by 2. So how do I undo the multiplication by 2? Well, I can now divide by 2. So I had 32 in the previous step. I divide that by 2. So 32 divided by 2 is 16. And then again, we started off with x. So we started off with x. So we're going to end with x. So what do we have? Well, we have that x is equal to 16. So this is one approach to undo an equation. I'll show you in another video how to solve this without writing all this stuff down, but the process is the same, and the thought process behind this is also the same as far as any equation that you encounter. You really want to undo the equation or undo what's happening to x.